Hi guys, so in this video we will be solving this problem number of islands 2. Okay, so let's first understand the problem. So the problem says that we will be given a row and column, means number of rows and number of columns. It represents a 2D matrix. We will be given k queries in the problem, and in each query we will be given a row and a column index. That a row comma column will be given to us. Initially in this matrix, every index is filled with 0. So whatever row and column value is given to us, we have to flip that 0 into 1. So, and 1 represents an island. 1 represents an island. We have to tell the count of islands at each after each query. Like, okay, so suppose if initially 0 comma 2 is given as input, so what we will do, we will flip this 0 comma 2 into 1. So what is the count of islands till now? Count of islands till now is 1. Okay, now suppose what 3 comma 1 comma 3 is given to us. So what we will do, we will convert this 0 into 1. So what is the count of islands now? Count of islands now is 2. So 2 will be stored now in this array. Okay, now suppose if 0 comma 3 is given as input, so we will convert this into array. Now how many islands are there? So now there are not 3 islands. This is a single island since it is connected. Okay, now again 1 will be stored in this. Okay, so this is what the problem is. So I hope the problem would have been clear. Now let's see how we are going to approach this problem. So what we can do is that there will be k queries. So and after each query, means a row and a column will be given to us. So what we will do, we will flip the 0 at row comma column index, and after that what we can do, we can apply a DFS and we can find the number of islands in this grid. Okay, so that will be what, k into the complexity of DFS. In this we will be achieving this, and this is not very good. Like, we can optimize this. So we will not be doing this. We will be doing it with some other way, via which what we will be doing is we will be using disjoint set union for solving this problem. We will applying this technique for solving this problem. What we will be doing is that first, for applying disjoint set union, like this is a 2D grid. So how will we apply this is that we will convert this 2D into 1D. How we can do this? We know that if we have a row comma column, we can convert it into 1D using this formula. One, that is whatever is the, if I want to convert r comma c, r into whatever is the columns, number of columns, like number of columns over here is 5 plus c. We can use this formula. Okay, so if I want to solve this problem using disjoint set union, so let's make some parent array. So we will be using 1 2 3 4 5 around 20. Okay, so let me make a parent array quickly. So then after that I will be explaining the algo, like what we are going to do. So let's make 1 2 3 okay, let me index it as well. 0 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. Okay, initially all, since it is a parent array, so initially it will be filled with -1. That, okay, I'm intentionally filling it. It will help us. Okay, so now let's continue with the algo. Now what we are going to do is that we will one by one process the queries. Let's suppose first query is what? First query is 0 comma 3. 0 comma 3. We will first convert it into what? 1D. So what we will get if you convert it into 1D? We are going to check 3. We will go to parent array and we will check at index 3. If index 3 is -1, then it indicates that this cell is 0. 0 means we are going to convert it into an island. And if it -1 is not present at index 3, then it means that it was already converted into 1 in the past. Okay, so that means that it is already converted into 1. So this will not increase our, means, island count. So we'll also maintain a variable count equals to 0. So we got 0 comma 3, we converted into 1D, we got 3, we are checking at index 3, it is -1. -1 means what? It is not converted into 1 yet. So we'll increase our count by 1. So we'll add 1 to our answer. Okay, so currently in our array we will store 1. Okay, now let's check the next element. So Suppose 1 comma 4 is the next element. Okay, so if 1 comma 4 is the next index, so we'll convert it into 1d to 1d. So what we will get, 1 into 5 plus 3, 8, eighth index. So we'll go and check eighth index. It is minus 1. Yeah, we have to change the parent array also. So we change it into 3. Okay, for 1 comma 4 we check at index 8, it is minus 1. Minus 1 means what? It is not converted into 1 yet. So we'll increase our count by 1 and change the parent to 8. Now it is stored over here. Okay, now suppose next element is what? Next element is 1 comma 3. 1 comma 3. So 1 comma 3, if we convert it into 1d, I will get 7. I will check at index 7, it is minus 1. I will increase my counter by 1. Since minus 1 indicates it is not converted into 1 yet, so I will convert it into increase 1 to my counter. Since I am going to convert 0 into 1, that means I am going to increase 1 island, so 1. But as now my count says 3, but initially but actually what, it is a single island. So instead of 3 it will be 2. Instead of 3 I should what, I should store 1. But how I'm going to know that my islands have decreased to 1? So what I will do is that each time when I convert a 0 to 1, what I will do, I will check in the 4 adjacent directions. Okay, I will check in the 4 adjacent directions. So when I check this left one, what is its 1d? When I convert it into 1d, I will get something as what? 4, 5, 6, sorry, 4, 5, 6, 7. I will go and check 7th index. 7th index is minus 1. Minus 1 represents 0. It is a 0. So no problem from this cell. I will go to this cell. I will check its parent array 3. At index 3, it is not minus 1. It is not minus 1 means what? Means it is a 1. So we are a part of the same island. So what I will do, I will decrement 1. Okay, now I will similarly I will check this particular side, 1 comma 4. When I check 1 comma 4, that is ninth index, I am seeing it is also minus, sorry, 1 comma 4. So 1 comma 4 will be 5 plus 4, ninth index. So I have not updated the value over here. So here it will be 9. Since I have changed 0 to 1, so here also I will change. So it was a mistake, sorry for that. So yeah, when I will check ninth index, I am seeing that here also minus 1 is not stored. Minus 1 not stored means what? Here also it is a 0. So we are a part of the what? Same family. So I need to decrement 1 from my answer. So finally what I will get, 1 plus 1 plus 2, 3, 3 minus 2, 1. So I am getting 1 and my island count is also what? 1. So this is what we are going to use to means to find the number of islands at any moment. Okay, so now let's suppose take few more example, let's do few more iterations. We got what, we are getting like what, suppose 2 comma 2, 2 comma 2 we are getting, our count is what, 1. So 2 comma 2 means what, we will 2 into 5, 10, 10 plus 12, we'll go to 12 index. 12 index is what, minus 1. That means we are it is 0, so we are going to convert it into 1. So I will add 1 to my answer and I will convert 2 comma 2 to 1. Okay, now I will check my 4 directions again, that are you 1? No, it is not. It is not. It is not. It is not. So answer will be 2 only. 2 will be stored in the array. Okay. Now let's suppose the next element is what? 2 comma 2. 2 comma 2 means 2 comma 2 is 10, 12. Index 12. I need to. Okay. Now let's suppose the next element is 2 comma 3. 2 comma 3. So when I will convert it into 1d, I will get 13th. 13th index is minus 1. That means what? It is not 1 yet. So I will add 1 to my answer. I will change the parent array to 30. I will convert it into 1. Okay. Now what I am seeing is that my count is saying 3, but actually there is only one island. So I need to perform that 4 directional check also. So let's check that. I will check to my left. I will check in this array. Okay, so it is not minus 1. That means it is a 1. So I need to decrement 1 from my answer. Okay, I will check to my right. It is 0. No problem. I will check to my bottom. It is 0. No problem. I will check to my top. What I'm seeing, it is 1. In the parent array also, it is what? Minus 1 is not stored. That means what? It is 1. So I need to decrement 1 from my answer. Now my answer will be what? 1. So I will store 1 in my array. So this is what, how we are going to proceed. So I have shown with parent array, but this we'll use find algorithm also, means we'll be using find also, and I will be using it in the code. So that part I have not shown over here, that we will be using directly in the code. So I guess the algorithm, like what we are going to actually do and how we are going to reduce the time complexity by following this approach is clear. So now let's move on to the coding part. Okay, so now let's code this problem. So as we are going to use the DSU approach, as I explained you. So let's start with making the parent and rank array. Okay, so we need a vector of integer parent of rows into columns. Let's initialize it with -1. Okay, rank of rows into columns. Okay, so what we were doing, we were one by one removing the elements, means finding queries. So for integer I equals to 0, I is less than position dot size plus I. What will be row? Row will be position of I comma 0, and column will be what? Column will be position of I comma 1. Okay, I will convert it into 1D. So cell 1D will be row into cell 1D will be row into columns plus of C. Now let's check if parent of this cell, that is parent of cell 1D, is not equal to -1. Then let's make a vector also for storing the answer that we will return. So let's make a vector of integer answer. We need a variable count also, that is the number of islands till now. So answer dot push back count and continue. So what we did over here just now is that what we did that, suppose 1 comma 3 is given to us, 1 comma 3 is already 1, right? And suppose again 1 comma 3 is given to us to make the 1. What we will do, we will check in this array 1 comma 3, that is at 8th index, it is not -1. It is not -1 means what? It has already been converted into 1. So my number of islands are not going to increase, it will be the same only. If any new cell is going to be converted into 1, then my number of islands are going to increase or decrease. But if a cell is already 1 and we are again going to convert it into 1, so no change will be there in the answer. So what we are doing is we are simply pushing the count, that is number count of islands, again back into the array. Okay, so this is what we did in this case. So after that, what we were doing, if this was not the case, then what we were doing, we were changing the parent array, right? The parent of cell 1D will be what? Cell 1D. We will increase the count also, that we are going to convert 0 to 1, that is increasing the islands, and we will also make rank of cell 1D equals to 1. Okay, after that what we used to check that when I make a 0 to 1, then I have to check in all the 4 directions also to ensure my answer, that if the number of islands are reducing or if something is happening. So for making that, we have to make 4 direction calls. Okay, so let's make 4 direction calls. So for integer I equals to 0, I less than 4 plus I. For making 4 directions calls, I will use a direction array. So let's make 2 directions array, direction array in X, and let's make one more direction array, vector of integer direction array in Y. Okay, so now what are the possible options? If we are at this location, I can go to up these 4 locations, and this is what? -1 0, this is what? 0 1, this is 1 plus 1 0, and this is 0 -1. These are the 4 directions. So this is what we are going to do. So direction in X will be what? -1 0 1 0. Direction in Y will be what? 0 1 0 -1. This is direction in Y. So now let's move integer new row will be what? Row plus direction array in X, and integer new column will be what? Column plus direction array in Y. Now new cell 1D, let's convert it into 1D, will be what? New row into columns plus of new column. Okay, now we have to check if new row is it lying in the board or outside the board. Like if we are at this particular location, like we cannot go to the left or down because it is out of the board. So we need to check that if it is inside the board or not. So if new row is less than 0, or new column is less than 0, or new row is greater than equal to rows, or new column is greater than or equal to columns, then we'll skip this node. Or there is one more condition, like if I am at this cell and I want 0, and if I'm checking this cell it is 0, like in the parent array it is -1, so it is not going to change my answer. Then I can skip these nodes. I have to consider only those nodes which are already 1. So if the parent array of new cell 1d, new cell 1d, if it is equals to -1, then simply continue. Okay, otherwise we have to check. Okay, so while checking, what we will check using find function. So suppose if not integer leader of x equal to find, and find what, cell 1d, and parent, and integer leader of y equal to find new cell 1d and parent. Okay, so what I'm saying is that there can be cases like, let's take one more example. Let's suppose one more example. If you take something like this, if we have some agreed something like this, 0 0 0 0 0 0 0 0 0, first we make this cell to 1. Let me change the color. First we make this cell to 1, then this cell to 1, then this cell to 1, then this cell to 1. Okay, now currently our count will be what? Our currently island count will be 1, since there is only one island. Now we are going to make this cell to 1. Okay, so what will happen? First I have changed this cell to 1, so I will increase my count by 1. Now my count is what? 2. Now what will happen? This cell will check to its neighbor. It will check to this neighbor. Is check that it is 1, so it will decrement 1. It will check with this neighbor, it is also 1, it will again decrement by 1. My final answer will be 0. But if we look clearly, our final answer is not 0. Our final answer is what? Number of islands is what? Number of islands are 1. So our answer should be 1. So why it is happening? It is happening because these islands, before making this one, these islands were what? Were part of a single island. Okay. So like if we check the parent of this island, in the find function, if you check the parent, so these four will have the same parent. So we can use that. We will check if the parent of both these, means all the adjacent cells, we will check if they have the same parent, then we will decrement only one time. Means we will not decrement it, otherwise we will decrement for each of the ones we find. Okay, so let's check that, or let me explain you that whatever I just now told. What will happen is that first time this one will make to this, will make call for this one. Okay, now our what will happen? We will decrement 1. Now this one is what? A part of this island, since we have joined this. Now this one will make call for the bottom one, but both these two will have what? Same parent, because of the find algorithm. When we will apply find algorithm, both of these will give us same parent, so we will not decrement 1. So our count will be what? 1 plus 1 minus 1, that is equal to 1 plus 1 2 minus, sorry, 1 plus 1 2 minus 1 equals to 1 only. So our answer will be correct. Okay, so we are going to do this. Okay, what we will do, we will find and we will check if leader of x is not equal to leader of y. Then one thing is that we will decrement the count, that is for sure. Okay, now we will check if parent of x, not parent, if rank of x is greater than rank of y, then what we will do? Parent of y equal to x. Else, if rank of y is greater than rank of x, then what we will do? Parent of x equals to y. Else what we will do? We can make anyone as parent. Let me make parent of x equals to y and plus rank of y. Okay, we have incremented the count, we are decrementing the count, and after this for loop gets over, what we have to do? We have to push answer dot push back count, and finally we have to return the answer also. Now we need to write the find function also. So let's write the find function. integer x and vector of integer parent. So if x is equal to parent of x, then what we will do? We'll simply return x. Otherwise, what we will do? We'll return parent of x equals to find parent of x comma parent. Okay, so I guess we are more or less done with the code. So let's try to run this code and see if it is correct or if everything is right. So there is some error. X was not, rank was not declared in this scope. We have declared rank. Rank of x is greater than rank of y. Where is that? Okay, it is not x, it is leader of x, leader of y, parent of leader of y, leader of x, leader, leader. Okay, let's check if there is any more error apart from this. Rank error, R does not name a type at line number 66. There is some error at line number 66. Okay, now let's try to run this code. It is giving correct answer. Let's try to submit it. Let's see if it is passing all list cases or not. It is passing, so it is the correct solution. So I hope you guys would have enjoyed the video.